high availability and data protection. So you build this great virtual infrastructure. You have all these virtual machines, all these new ESX hosts, all this entirely new infrastructure in your environment. But how do you ensure high availability, and how do you make sure your data is protected in the form of backups and restores, etc., etc.? It is not enough to just virtualize the environment. How do I ensure extreme uptime? And on the other hand, how do I make sure that my data is safe? How can I make sure that I'm ready for disaster recovery, business continuity, etc., etc.? And you'll notice that data protection is one of the hottest topics in the IT world today, simply because of all the natural disasters, the terrorist disasters, the epidemics, the pandemics, all sorts of disasters that can happen that would require any organization, whether you're doing this for a virtual infrastructure or a physical infrastructure, to have high availability for the local environment and your corporate world for business continuity, and to have data protection for disaster recovery in order to ensure that a business can survive a disaster of any nature. This module is going to focus on how we can leverage virtualization, what are the tools that are available to us within our virtual infrastructure to leverage high availability and data protection. So some of the topics we're going to be covering, we're going to be talking about the VMware High Availability Cluster. We're going to be talking about high availability in itself. We're going to move on to fault tolerance. Then we're going to talk a little bit about data protection as far as VMware Consolidated Backup and the Data Recovery Appliance. So let's start off with high availability. What is high availability and why do you need to use it? High availability automates the restart of virtual machines when a host fails. So the beauty of having high availability is you have 2 hosts or 3 hosts in your ESX cluster. If an ESX host fails for whatever reason, the remaining ESX hosts in that cluster are going to power on the virtual machines, bring the environment back up. And the reason they can do that is because all of the ESX hosts in that cluster can see the same shared storage. Once the cluster notifies the host that there's been a host failure, then the remaining VMs or the VMs that have failed are going to automatically be restarted on the remaining hosts. Now yes, there is downtime, but there is minimal downtime. Now if you compare that with a physical environment, if a physical server goes down, sometimes it's not enough to go in there and reboot that server and bring it back up because you have physical components that have failed. In the case of virtualization, even if you have the ESX host with physical components that have failed, the virtual machines that were running on that host can now be restarted by the remaining host. So now you have minimized downtime down to minutes rather than hours and days, as was the case in the physical world. But now for some of those applications that require extreme high availability, we're going to later on in the next slides talk about fault tolerance and how to ensure that these applications and these virtual machines can literally stay up and sustain even an ESX host failure. So high availability is going to also provide virtual machine monitoring and fault tolerance, which I just mentioned, but the virtual machine monitoring allows the cluster to monitor each individual virtual machine so that if one virtual machine fails, it is automatically restarted. This has nothing to do with the host at that point. It is monitoring the actual guest operating system within the virtual machine, and if it doesn't receive a response or a heartbeat from that guest operating system, it's going to assume that this virtual machine is down or corrupt or not working, and it's going to try to reboot it to rectify the problem. Now, high availability can be centrally managed and configured from within Virtual Center, which is the beauty of the virtual infrastructure using vSphere. Everything is a plugin to Virtual Center. You have one console you have to worry about. Now let's move on to fault tolerance. What is fault tolerance? It is one of the coolest features that VMware vSphere 4 has introduced. Fault tolerance allows you to have 2 virtual machines that are running on 2 separate hosts to be in lockstep of each other. And what lockstep means, it's actually vLockstep technology that's developed by VMware. What that means is you're going to have a primary VM and then you're going to have a secondary VM that lives in its shadow. The primary VM will make an instruction mirror of the first VM on the secondary, which means every task that is applied on the primary virtual machine gets automatically applied at the same time on the secondary virtual machine. And you'll see during the demonstration, when I click on the start menu on both virtual machines is going to come up. If I go to the run menu, both of them at the same time. If I run a video, you're going to see the video play on both screens. Now what happens is these two virtual machines are living on two completely different ESX hosts. You have the primary virtual machine that's in production. The secondary virtual machine is living in its shadow. If that ESX host that's hosting the primary fails completely, the secondary virtual machine will automatically assume its personality from a host name perspective, from an IP perspective, from the entire stack's perspective, and you won't even lose a ping. And we're going to show you that in the demonstration. And it will continue to service the users and the applications with no interruption whatsoever. Now, fault tolerance obviously has some requirements and some limitations, and we'll talk about that in the next slide. But fault tolerance is an extremely promising technology. It is basically a clustering technology taken to the next level. And the ease of use of fault tolerance, the ease of setup and configuration and management of fault tolerance is what makes it, or what gives it its appeal, its beauty. Alright, let's move on to the fault tolerance requirements. I've listed some of the requirements here for you. In order to use fault tolerance, you're going to need an HA enabled cluster, obviously. You're going to need ESX and ESXi to be running at the same build. So it's not enough that they're running at ESX4, for example. They have to be running at the same build. So if you're running ESX4 update 1 or update 2 in the future, etc., they have to be at the same patch level. You need a gigabit NIC, a dedicated gigabit NIC for fault tolerance, and we'll see that during the demonstration. So the same way you dedicate a physical NIC to vMotion, you want to dedicate a physical NIC to the logging of fault tolerance, so that fault tolerance uses that gigabit NIC on the back end to make sure that the primary VM is synchronizing all of its tasks with the secondary VM with no interruption and without affecting traffic on the network. So that's why you give it a gigabit NIC. You need shared storage in order to make fault tolerance work. Obviously, that's most of the enterprise level features that we have with virtual infrastructures today need shared storage. And then one of the most important things you need to pay attention to when you want to use fault tolerance, or if you intend on using it and you want to buy hardware, you want to consult with the VMware Knowledge Base article that I have on screen here that allows you to see which CPUs and guest operating systems are supported by fault tolerance. Fault tolerance also has some limitations from the memories, from the virtual machines perspective, in that it's only limited to one vCPU. So you can't have a virtual machine with more than one vCPU, which is a limitation. But again, every technology has certain limitations to it. You can't do snapshots with a fault tolerance enabled virtual machine, and you need your virtual machine hardware to be at version 7 in order to take advantage of this technology. Now, with regards to snapshots, if you have an application that you're doing such high availability for, then it makes no sense to take snapshots, because you're not going to try and install software and do testing on such a high priority or high level application. So that's why losing the snapshots for this particular application isn't a big deal. But if you wanted to take advantage of snapshotting or testing this virtual machine, there's no reason why you can't clone it, run all your snapshots against the clone, and if your testing works, then you can apply that into the production virtual machine that's running the fault tolerance. Alright, let's mix it up a little bit here, and let's bring up a whiteboard and talk a little bit about the different types of clustering that we can do in a virtual environment. Alright, so these are the types of clustering that you can do. We can do what's known as a cluster in a box. So basically you have one ESX host. Inside of this ESX host, you have virtual machines. So you can cluster the virtual machines that are inside the ESX host. Now granted, if the ESX crashes, if the host crashes, then your clustering is useless. But if you're worried about the VM, and if one of the VM crashes, then you have another VM, which is another part of the cluster that's still up and running. So this is one form of clustering that you can do. Now, to get a little more creative and a little more in-depth, you can do clustering across hosts. So you have ESX01 here that has a virtual machine, and then you have ESX02 that has a virtual machine, and you want to cluster those two. So you're clustering the virtual machines across hosts. So what happens is, in the event that the entire host goes down, you're still okay because the VM is running on another host. Obviously, their files would be running on the SAN, and you're up and running, no problem. Now you can also do clustering between a physical box and a virtual machine. So let's say your organization is not ready to go to run entirely on a virtual machine, but you also want to take advantage of VMs and virtual machines, so you can cluster between physical and virtual. So you have your physical file server here, and you can cluster it to a virtual machine that's running inside of an ESX host. Again, the common denominator here is the SAN, the same as it was with the cluster across multiple hosts. Now you're probably asking, but what about the SAN in the cluster in a box? Now the SAN in a cluster in a box up here doesn't really matter. I mean, even though the VMDK and all the data is going to be running on the SAN, if the ESX host goes down, there's no VM to access the data. So the SAN up here is not very helpful. So this is traditional clustering. Now let's take a look at what VMware offers in terms of a proprietary solution. So let's take a look at VMware High Availability. So in a VMware High Availability cluster, what you do is you create a cluster, and the members of this cluster are the ESX hosts. So let's say you have 2 ESX servers, which are hosts, in your environment. You create a high availability cluster of these 2 hosts, as we have drawn here in this picture. So you have ESX01 and ESX02. ESX01 has 4 virtual machines running on it, whereas ESX02 has 3 virtual machines running on it. Now both hosts are connected to the SAN. All the available LUNs on the SAN are visible to both ESX hosts. Now obviously the VMware High Availability Cluster is controlled through Virtual Center, and as such that's the need for the Virtual Center server here. So how does it work? The High Availability Cluster, what it does is, in the event that a host goes down, you can power on the VMs that were available on that host on another host. So in the event of a loss of ESX01, for example, VM 1, 2, 3, and 4 can be powered on via ESX02. In this scenario, yes, there is downtime, but the downtime is so minimal that it's a matter of minutes. It's the time the virtual machine requires to boot up. Now, granted, the virtual machine treated just like a normal physical machine in the event of a crash, so long as the operating system can boot back up and is not corrupted, it's going to bring it back up on ESX02. So let's assume everything is going to go the right way. ESX01 crashes, all 4 virtual machines should be able to power on ESX02 and be back in production in less than 10 minutes. Now some prerequisites for this high availability cluster to work. First of all, DNS between the ESX hosts should be configured properly. You should be able to resolve all the ESX hosts via DNS name. And obviously all ESX hosts should have access to the common resources in order to power on that virtual machine. So if ESX02 doesn't have access to a LUN where VM2, for example, its configuration files and its data resides, then it won't be able to power it on. And as such, obviously, you won't be able to bring it back up, and defeats the purpose of the high availability. So you want to make sure that you're able to power on the VMs among all the hosts that are going to be part of the cluster. So let's log into Virtual Center and create our first VMware High Availability cluster. In Virtual Center, in order to add high availability to a cluster, we're going to go to Hosts and Clusters. We're going to right-click on a cluster and drag down to Edit Settings, and then at the cluster features, we're going to enable high availability. And you'll notice here that we already have DRS enabled from the previous module. So to go through the cluster features, what we're going to start with is VMware HA. And you'll notice here that you have Enable Host Monitoring. Now, what Enable Host Monitoring allows you to do is it allows the VMware HA cluster to monitor all of the ESX and ESXi hosts that are members of this cluster. Now, why would you want to disable this checkbox? This checkbox can come in handy if you're trying to put certain hosts in maintenance mode, or if you want to take them out of HA or disable HA without actually coming into the cluster features here and completely removing it. So it is best practice when you want to disable HA for whatever reason to come in here and disable host monitoring rather than removing VMware HA completely from the cluster. This allows you a way to put some hosts in maintenance mode without actually disabling the entire high availability cluster. Another reason for disabling host monitoring is if you're going through an exercise where you have network monitoring or network maintenance in place, where the physical networks, for example, are going through a maintenance. That could possibly put certain ESX hosts into isolation mode if the service console or the VM kernel network is connected to a physical switch, or a redundant physical switch, or for whatever reason you have network maintenance that might affect your ESX environment. If you don't disable the host monitoring, then you're going to get admission control policies that go into effect, and the virtual infrastructure is going to think that there's a problem with this particular host, and it's going to try to isolate it and restart its virtual machines on different hosts and create a whole slew of problems. So this gives you a way to disable host monitoring without actually disabling the entire VMware HA cluster. Host monitoring is also useful for fault tolerance. Fault tolerance relies heavily on host monitoring because it needs to know when a host fails so it can restart the secondary virtual machine that is available on a different host. So very useful here, and can come into handy again when you want to disable HA without actually taking it out of the cluster. Now the second option here is admission control. Now admission control allows you to ensure that sufficient resources remain to provide high availability in the event of an outage. So what that means is, with admission control, so for example we have two options here. We have enable, which means do not power on VMs that violate available constraints. So what happens is, if an ESX host fails, the VMware HA cluster is going to look at the remaining resources in the cluster. If it finds enough resources to power on all the VMs, then great. But if it doesn't have enough resources to power on all the virtual machines, that not all virtual machines will be powered on. Only enough virtual machines will be powered on to satisfy the availability of resources. Now the second option here means if you disable that, that means virtual machines are going to be powered on even if CPU and memory resources aren't available in the cluster, which means there's going to be resource overcommit in order to satisfy those virtual machines and bring them back up. By default, it's obviously set to enable. Now we come down here to specify the type of policy for admission control. What do you want to do? You want to specify how many host failures, for example, you want to be able to tolerate. The amount of host failures you can tolerate in a cluster all depends on how much resources you have in that cluster. For example, in my cluster I only have 2 ESX hosts. So there's no way I can tolerate more than one ESX failure. But you're going to have ESX, or you're going to have clusters that have more than 2 ESX hosts in them, 4, 6, 8, whatever the case might be. In that case, you'll be able to specify, I want to be able to tolerate 2 ESX host failures. But you want to make sure that the remaining ESX hosts in that cluster have enough resources to power on the virtual machines, or to take on the virtual machines from 1 or 2 ESX hosts. That all is going to depend on your capacity planning and how you've designed your environment from a high availability perspective to take into consideration that you want to tolerate 2 ESX host failures. Make sure the remaining ESX hosts have enough resources on them to take on the virtual machines from those failed hosts. Now you can do that by specifying how many ESX hosts you want to tolerate. The other option here would be to tell it how much of the cluster's resources you want to reserve for failover. So if you say 25% and you have 6 ESX hosts in this cluster, then it's going to carve out 25% of the resources of these 6 ESX hosts and keep those as reserved resources that only come into play when you have host failures. So that's the second option, which is a percentage of the resources within the cluster. Now the third option is very traditional. What you do with the third option is you're pretty much specifying a spare. A spare is just a server that's sitting there that has enough resources, that is not doing anything, that is waiting for an ESX host to fail in order to restart the virtual machines on this spare ESX host. Now the trick is, with this spare ESX host, you can't vMotion virtual machines to it. DRS can't move any types of VMs to it. So that host is literally sitting there with CPU and memory resources doing nothing, waiting for an ESX host failure. Now, if you ask me, that is a horrible option. That defeats the purpose of virtualization altogether. Why would you do that? Why would you have an ESX host that's sitting there collecting dust for the most part, that has CPU and memory resources that you could be utilizing, not do anything except wait for an ESX host to fail? It defeats the purpose of virtualization. We are trying to minimize the amount of physical servers that aren't doing anything, and I've been telling you all along this course that only 10% of all physical server resources are used typically in the physical world, and here we are giving you an option to specify a host as a spare. So this is very traditional, very old school thinking ways of taking care of a cluster. If you can add it back into the cluster and use the second option to reserve a percentage of the cluster's resources, then why not put that host in the cluster and take advantage of it? Load balance across all the available ESX hosts rather than make an investment in an ESX host that you're never going to use unless a host fails. To me, it just gobbles my mind. To me, the first option is always going to be my favorite. Design your environment properly. Make sure you have enough resources in the environment to take on an ESX host failure and spread it out accordingly. Now, if you have ESX hosts that you're adding at a later stage, you're not designing the environment from the beginning, and for whatever reason you didn't do the right capacity planning, then you can always go with option 2, which is a percentage of the entire cluster's resources, which is a fantastic option. Now we're going to move on here to virtual machine options. Now with virtual machine options, it gives you the ability to prioritize the restart of virtual machines in the event of a host failure. So what you want to do is, by default, the entire cluster setting is set to medium. Now you have options here of setting it to disabled, which means you're not restarting any virtual machines in the event of a host failure, low, medium, and high. By default, the restart priority is medium. You have the host isolation response. What host isolation response means is if the service console loses connectivity with the physical switch, that's in ESX, or if the VM kernel network in ESXi loses connectivity with the physical switch, that puts the host in an isolation mode. Because as far as the host is concerned at that point, it's lost connectivity with the network. But you might have physical NICs that are dedicated to virtual switches that serve virtual machines that are unaffected by that outage that your service console or VM kernel network is experiencing. So in this case, this is called a host isolation response. What do you want the host to do if its service console or VM kernel network loses connectivity? Do you want the virtual machines to stay up and allow you to rectify the problem because you're going to have alarms set up, you're going to have SNMP traps, etc., and you're going to be notified that this interface is not communicating, which in my mind would be the best option, is to leave the virtual machines powered on. But you have options. What do you want to do in the event of a host isolation? You can power them off and then you can shut down. So these are three options that you can choose from. I would always go with leave powered on and allow you to take the necessary action, or give you enough time to try to rectify the situation. Now in this box down here, this gives you the option of overriding the cluster setting as far as the VM priority is concerned. By default, you're going to notice that the VM restart priority is taking the cluster default, but if you select it, for example, you can always override it by giving certain virtual machines a higher priority in the restart queue. So for example, if you had domain controllers and Exchange servers and SQL servers, you want to make sure your domain controllers come up first, so those get higher priority than, for example, your file servers. So this gives you the ability to prioritize VM restart. It also gives you the ability to override the host isolation response. So what do you want to do for this particular virtual machine if a host isolation goes into effect? Now obviously you can always go with the cluster settings, but if there are virtual machines in your environment that you want to move off of a particular host that's experiencing a problem, even if that's a fluke with the physical switch and not necessarily anything to do with ESX, but just because you want to be on the safe side, you can set policies on what to do in the event of a host isolation based on virtual machine importance, and you can take care of that right here. Alright, let's move on to VM monitoring. What this allows you to do is it allows you to monitor the virtual machines that are running in the cluster through VMware tools by leveraging heartbeats. So VMware tools will constantly send heartbeats back to the cluster, letting the cluster know that this virtual machine is still alive, that the guest operating system within this virtual machine is still functioning properly. Now what happens is, if the guest operating system stops sending heartbeats, so the VMware tool service stops sending heartbeat back to the cluster, that cluster will automatically restart the virtual machine in order to rectify the problem. Now before restarting the virtual machine, and to help diagnose issues, virtual machine monitoring will capture screenshots of the console before it actually reboots it. It'll actually capture up to 10 screenshots, and it will save them in the same location where the VM's configuration file is, so wherever the VMX file is. So by turning on Enable VM Monitoring, again, it will leverage the VMware tools that are installed in every virtual machine, They'll send heartbeats. The guest operating system will then send heartbeats to the cluster, notifying the cluster that I'm in good shape, I'm healthy. If the cluster doesn't receive a heartbeat from that virtual machine, it's going to automatically know that there's a problem with this virtual machine, and it's going to restart it in order to rectify the problem. Now what we have here is the default cluster settings, and it gives you the monitoring sensitivity. How aggressive, how often do you want me to monitor these virtual machines? How much do you want me to monitor these virtual machines? You can set this as high as you want or as low as you want, or you can go with custom settings here, which allows you to do failure intervals, allows you to do minimum uptime, maximum per VM resets, so on and so forth. You can tweak these settings any way you want to. So for example, with the failure interval here, you can wait up to 30 seconds, for example. If that heartbeat doesn't get received, then you reboot it. With the minimum uptime, same thing. You have maximum per VM resets. So how many times do you want to, you want me to keep rebooting this virtual machine if I'm not getting a heartbeat? Or do you want me to stop after 3 times? What is the maximum per VM resets that you want me to do? Now from there, let's focus our attention down to this small box down here. Now over here, it gives you the option again, as with all of the other options with high availability. If you wanted to override the cluster settings, you can always select the virtual machine and override it with, again, either high, medium, low, disabled obviously, or if you wanted to put in some custom settings. If you click on custom, it's going to open up another window here. Let me try to bring it within focus. And you can enter or input the values that you want for that particular virtual machine. So that's another way of overriding the cluster settings on a virtual machine basis. And that pretty much sums it up for VMware HA, folks. So what I'm going to do now is I'm going to click on OK to exit out of the cluster. And now let's take a look at the coolest new feature with VMware vSphere 4, and that's fault tolerance. We're going to start with ESX01. We're going to go onto the configuration tab here. Now you'll notice that I have a virtual switch for vMotion. Now best practice dictates that vMotion and fault tolerance be on separate virtual switches with separate physical NIC cards. For the purposes of my example, I'm actually going to put them on the same virtual switch, since this is just for demo purposes. The process is the same. You would create a virtual switch, you would come in here, you would add a vkernel port. In my case, the vkernel port is named vMotion. I have it in the right VLAN, and instead of enabling vMotion, you would enable logging. Now logging is basically enabling fault tolerance onto this port group. So I'm going to go ahead and enable it together with vMotion. I'm going to get a warning message as soon as I click on OK that best practice dictates you have them on separate networks. I'm going to go ahead and click yes to say yes, I'm sure. We're going to click on close. And we're going to do the same thing on ESX02. I'm going to go to the configuration tab here. Down here under the vMotion virtual switch. Whoops. We're going to select vMotion. We're going to click on edit. We're going to select enable as far as fault tolerance logging is concerned. We're going to click on OK. That same warning message, we're going to accept it. We're going to click on close. Now, if I told you guys that's it, you're done. You can now do fault tolerance with any one of the virtual machines that you choose. Would you believe me? It is that simple. Now watch this. Check this out. This is really cool. Alright, now let's pick on a virtual machine and enable fault tolerance on it. I want to show you guys how easy this is. One click and we're going to enable fault tolerance on a virtual machine. That is almost unheard of in any clustering software. We're going to pick on MPCTX icon 05. We're going to right click on it, drag down to fault tolerance. We're going to turn on fault tolerance for this virtual machine. This message box is basically saying that it's going to commit the memory, it's going to commit hard drive, so you can't use thin provisioning and stuff like that. We're going to go ahead and click on yes. And in a matter of seconds, you're going to notice that it's already creating the secondary virtual machine. And you'll notice it here. Now this will take a few more seconds before the status is 100% complete, and then we can run some tests on this VM. This is really cool stuff. Fault tolerance is definitely the coolest feature of vSphere 4. Okay, so the secondary VM has been properly configured. It's now up and running. So what we're going to do is we're going to right click on our primary. We're going to open the console, and you'll notice that I've already browsed to the Apple website here. I'm also going to go to the secondary and open its console. Now I'm going to try to put them side by side here as much as I can without cluttering the screen too much for you guys here. We're going to move this up to the left. Now before I actually start the video and start this demonstration, watch this. You click on Start, and the Start menu, let me just move this a little bit so it's more visible. And the Start menu on the secondary VM appears. You go to Run, it moves it to Run. No matter how you highlight the mouse, it follows you. It instantaneously copies the instrument, the memory instrument, from one VM to another. Any task you execute on the primary gets executed on the secondary. This is really, really cool stuff. So what I'm going to do now is I'm going to go ahead and start a ping session onto this virtual machine, a continuous ping. Then I'm going to start the video in the background, so the video is going to be running on both virtual machines at the same time. And then from a different window, I'm just going to go ahead and reboot one of the ESX hosts and see what happens. So let's go ahead and do that. So I'm going to go ahead and click inside of this virtual machine. We're going to click on Watch, and then I'm going to reboot one of the ESX hosts. And we might have to play this video once or twice until the reboot process actually takes place. This is really cool stuff. You'll notice that the virtual machine on the right will automatically turn off, and the virtual machine on the left will continue to function properly. Let's go ahead and run this one more time. Notice the ping times. We haven't lost a single ping, which is great. Now that all depends on your network. Again, my network is just a lab, so I might lose a ping. Hopefully we won't lose a ping, but depending on the network, if the network is properly configured, then you shouldn't see any ping losses, and the transition from VM to VM should be flawless, should be perfect. Now you'll notice that the virtual machine on the right has lost connectivity. The virtual machine on the left has immediately assumed its identity. It continues to function without any interruption. You guys have noticed we've lost no pings. So as far as the user is concerned, you've lost no pings. Your virtual machine is completely running regardless of what happened to the ESX host that it was running on. Now, if you guys can find me high availability that can rival this, please bring it to my attention. I'd love to see it. This is high availability to limits that we've literally haven't seen before. Yes, there's clusters, but you gotta admit, this has a different feel and twist to it than anything else we've ever seen. So I'm going to cancel this continuous ping. Now what I'm going to do is we're going to wait for that ESX host to come back online. Then I'm going to show you how we can turn off fault tolerance, and we'll talk a little bit about what happens now. So in my cluster, I only have two ESX hosts, ESX01 and ESX02. If in a different cluster you had more than one ESX host, what happens right now is the virtual machine will now create a secondary virtual machine for itself on a different host. In my case, I only have two hosts, so when it goes to try to create a secondary VM, it can't because there's no secondary host. Once my host comes back online, this primary virtual machine will create another secondary for itself to replace the primary that went down, and so on and so forth. Again, because my cluster only has two ESX hosts, they have to wait. If in your cluster you have multiple ESX hosts, then this process would kick in automatically. It would automatically create a secondary VM for itself, and the process continues as normal. Now, you're going to ask, well, what happens if that primary virtual machine comes back online? That primary virtual machine comes back online, it goes into a queue, so it won't take over its role. That's it. Once the role has been taken away, the identity has been seized, that virtual machine now resides on a different host in a standby as a secondary VM and never ever becomes the primary VM again. Alright, now that the ESX host is back, let's go ahead and close out of this command prompt here. Let's minimize our virtual machine. And what I'm going to do is let's go ahead and right click on MPCTX Kernel 5 again and drag down to fault tolerance. Now you'll notice here that you have several options. You can turn off fault tolerance altogether. What that will do is it will take that secondary VM and destroy it. You can disable it temporarily if you don't want to use it. You can migrate the secondary, so if you want to migrate the secondary to a different host, you can do that. You could test the failover, and you can test the restart of the secondary. So these are all options that you can use to manipulate fault tolerance. For the purpose of this example, let's go ahead and turn off fault tolerance on this virtual machine, and we're going to click on yes. Now watch this. This is the console, the secondary virtual machine. As soon as it destroys it, obviously it's going to close the console, destroy the secondary virtual machine, and bada bing, bada boom, you're done. Now guys, I don't know what to say. I mean, this thing speaks for itself. The usefulness, the amount of things you can do with this are just amazing. Yes, it has some of its limitations, but every masterpiece has some limitations, right? I mean, they're going to continuously try to improve on this. The point to take here is typically with clustering, there's a lot of cabling that you have to enable. The application has to be aware. It's not a very clean process. Here, as you guys have seen, it's literally a couple of mouse clicks. You can't beat how easy this is, and you get the highest levels of availability. I mean, you guys saw I was expecting 1 or 2 ping losses. We didn't even get one. And this is a lab environment. Just imagine in your production environments what you guys can accomplish with a feature like this. Folks, this is the power of vSphere. Let's move on to data protection. Now, prior to vSphere, there was only one way to do backups using VMware native tools. You could only use VMware Consolidated Backup. There were other third-party tools and utilities that you can use, but from a VMware perspective, VMware Consolidated Backup was the native tool that was available. Now with vSphere, we have additional options that we're going to talk about during this module. But let's start off with, well, what do I need to backup? So the following 3 items here are VMware best practice. VMware recommends that if you're using ESX, back up the Service Console. If you're using ESXi, make sure you back up its configuration, and then you want to back up the virtual machine data. And the reason we're saying the virtual machine data is there's no reason to back up the virtual machine's operating system. Operating system should be static. But if you wanted to do that, that is an option that's available to you, where you can back up the entire virtual machine. It's like an image. You just take an image of everything, and we'll talk about that. But I want to touch on a few things here. While you can, and best practice dictates that you should, back up the Service Console for ESX and the configuration for ESXi, in my opinion, it's a waste of time. Reconfiguring ESX from the Service Console's perspective or the ESXi configuration perspective is very easy, very straightforward, and is not that much time consuming. And you can always leverage ghosting and imaging technologies to do that. But from a VMware best practice, you should take the following 3 steps as far as backups are concerned. Now, let's talk about VMware Consolidated Backup, and we're going to bring up whiteboards and talk in very detail about VCB, but I just want to give you a very brief overview. So VCB is a framework that allows third-party tools to plug in and use it. So for example, it allows applications like NetBackup and Commvault, etc., to plug into VCB, leverage that architecture, but use their GUI, their tools to control it. It eliminates the need for an agent in every virtual machine, and we're going to see that during some of the whiteboarding here. It uses a proxy server to consolidate backups, and we're going to see how that works as well. Eliminates over-the-network backups, so you can do everything on the same storage. You don't even have to get out to the network if it's configured properly, obviously. You can do file level, incremental, and full for Windows operating system, and then you can do image level backups for any supported operating system. Now let's talk about data recovery. So this is a new feature that was available or that was released with vSphere. It's appliance-based backup and recovery. It integrates with Virtual Center. So again, you guys see how a Virtual Center becomes that umbrella that allows these different components to plug into it, leverage it, and use it. And then you can only use the appliance or the data recovery model with a disk as destination storage. So that's one of the limitations, if you want to call it, of data recovery, is that your destination has to be a disk. And then one of the pros for data recovery is the simple interface, how easy it is to set up, how easy it is to use it, how easy to do backups and restores, etc., etc. All right, so let's go ahead and get into some of these whiteboard sessions. Let's get into some of these demonstrations. Let's have some fun. There are many ways by which you can back up your data. You can do a full virtual machine backup using VMware Consolidated Backup. You can do a Windows file level backup also with VMware Consolidated Backup. And you can do a file level backup using an agent. So I'm going to go over these points from the bottom up because I'm going to go from the least complex to the most complex. So let's first take a look at file level backup with an agent. A file level backup with an agent is the same way you would back up a physical machine. So let's say your backup solution right now is Veritas NetBackup, for example. So in the traditional sense, you would have your physical machine, you would have your operating system, your OS, and then you would have an agent running on this OS that would do the backup for you. Well, the same applies for a virtual machine. You have your VM here, and you have your OS, and you would install an agent, be it Veritas or something else, to back up the data on your VM. This would be considered a file level backup with an agent. Now, before we get into these 2 points, let's take a look at the VMware Consolidated Backup. The concept of VCB, or VMware Consolidated Backup, is really cool. Let's bring up the slide here and talk a little more in detail about the way it works and the way it functions. Alright, so with a VMware Consolidated Backup, you take the strain or the pressure off of the virtual machine or the ESX host. So in this backup architecture, neither the VMware nor the ESX host will have any performance affected by the backup, because the backup doesn't actually take place on neither the VM or the ESX host. Now let me explain this in a little more detail. So the idea behind this is to have a backup proxy server that handles the backup directly from the SAN. So you have an ESX server host here with 1, 2, 3, 4 VMs, whatever. Those VMs reside on the SAN. Now ideally, and the way VMware recommends that you prepare for your backup, is to have multiple VMDK disks. So you would have a VMDK, for example, for your operating system, and then you would have a VMDK for your data. So the first VMDK would hold, for example, the OS and the applications. The second VMDK would hold the data for those applications. Now obviously both these disks will reside or will live on the SAN. So the idea of the backup proxy server here is the backup proxy server will have the VCB, the VMware Consolidated Backup software, loaded on it. This should be a physical box, by the way, with Windows Server 2003, a fiber channel HBA, obviously, in order to connect to the SAN. It would have the VCB software loaded on it, and it would access the VMDKs directly from the SAN LUNs. So it would take out the VM and the ESX host completely out of the picture. It's accessing those VMDKs and those files inside those VMDKs directly from the SAN. So it's taking upon itself the backup pressure and the backup the strain of the backup, and relieving the ESX host and the VMs from any performance degradation that can be affected from backups. Now let's make this a little more interesting. If on your SAN you had, let's say, your tape storage is also located on the SAN, then what happens is it will back up directly to the tape backup located on the SAN, thereby completely eliminating the local area network. It does not leave the SAN. The traffic does not leave the SAN. It's kind of a copy inside the same volume from one place to another, from the VMDK to your tape backup. This is what's known as a LAN-free backup. Now, assuming your tape storage is not on the SAN, then it would obviously have to offload it from the SAN off to the tape backups storage, and then the LAN would be involved. But ideally, in an ideal environment, you would go within the SAN, which would be a complete performance increase, and as a result, the backup proxy would also not take a performance hit. Could I say a significant performance hit? Now, with VMware Consolidated Backup, you have 2 ways of backing it up. As we mentioned before, you can either do a full VMDK backup, whereby you're backing up the whole disk, the full VMDK disk. You're just taking it as a file and backing it up. Or you can do a Windows file level backup, which obviously means you can back up you can back up files within the VM, provided that it's running the Windows operating system. Okay, so we talked about a lot of the cons, or a lot of the pros that are available with VMware Consolidated Backup, such as being able to back up LAN-free. If your tape backup, for example, is fiber channel attached, it integrates with existing backup solutions, no resource performance hit on the ESX host or the virtual machine, and most importantly, you don't have to buy a backup agent for every virtual machine, because that could be very costly. If you're buying Veritas, for example, and I keep picking on Veritas simply because I've worked with Veritas a lot. I'm not recommending a vendor over another here, but let's assume you were to buy a backup agent for every VM you have. VMs quickly grow out of control in terms of the number of VMs that you have in your environment. Thereby, licensing would be very costly. So the advantage of using VMware Consolidated Backup also is you eliminate the need for an agent, for a backup agent on every single VM. Okay, so we've covered backups, but backup on its own is useless if we cannot restore it. So now let's take a look at the way we can restore the data and bring it back into a usable format. Now obviously, if you're using the traditional method of backing up, which is to have a backup agent on your virtual machine the same way that you would on your physical machine, then the restore process is the same, and we won't get into that. But if you're using VMware Consolidated Backup, then there's a few options and a few things that you need to be aware of in terms of the way you can restore. So let's tackle that. All right, let's bring up that slide here and talk a little more in details about the three methods of restoring data. So we have the first method is centralized. In a centralized method, you have your proxy backup server here. Let's call it the backup proxy. And then inside the backup proxy server, you have your backup agent that's running. Now, the backup agent is used to back up the VMs, and in this case, it's also used to restore files. Now, because the backup agent is running on the backup proxy server, where do the restores go? The restores go on the backup proxy server inside of a directory. So when you're doing a backup, you do the backup. When you're doing the restore, though, it restores it into a directory on the proxy server, and then what you would do is you would use, because the backup proxy server is a Windows operating system, you would use a Windows share to copy the restored files back onto the VM, provided that if it's a Windows VM that you're copying it back to, it makes things very easy because you can UNC to it, copy the files, and you're done. If not, you would have to mount and move the files back. The point, though, is here is an administrator would have to copy the files manually from the backup proxy server to the VM. Now, the per group restore is a little more, it gets a little more in-depth, and it allows you to delegate administrator permissions if you want to allow to have multiple backup or restore administrators. This allows you to do that. Now, the concept here is to break up your virtual machines, for example, into departments. You can break it up into whatever makes sense for your organization, but for the purposes of this example, we're going to break them up into departments. So let's say you have the accounting department, and you have all the VMs for the accounting department here. And then you have maybe, I don't know, the say marketing department. And then you have their VMs here. Now the idea here is to select one of the VMs in every department and install the backup agent on it, or so choose one VM, install the backup agent. After that, you assign one backup administrator the task of restoring the files to those VMs. Now, the backups still occur on the backup proxy server. You're using the backup agent here only for the restore process. You're not using it to back up the VMs in any way. So after you back up the VMs and you need to restore them, you've delegated permissions to an administrator to restore the data. The data is restored on one of the VMs in every department, and then the administrator that did the restore will go in, take those files from the directories off of this VM that's designated for the restore files, and copy it back to where it needs to go. And finally, we have the third option, which is the self-service option. In this option, every VM gets a backup agent. And again, and I want to stress this, the backup agent that's being installed in every VM is being installed for the purposes of restore only. It is not used for backup. The backup still occurs at the backup proxy server level. So, you're using the backup agent here only to restore the files back into the virtual machine. Now, based on the size of your organization and based on the amounts of restores that you do, some organizations will do a lot of restores. Some organizations won't do a lot of restores. It all depends on the policies that you have in place, on what you decide that you will allow to be restored and what you will not allow to be restored, what you're backing up and what you're not backing up. If somebody loses a screensaver, are you willing to restore that? If you're going to that level, to that extent, then you're going to have a lot of restores. If you're not going to that extent and your data, you know which data needs to be backed up and which data needs to be restored and which data you can tell the user, you know what, this is personal stuff. We're not backing it up, or we're not backing up from the local C drive, for example. If you have something you want to back up, you put it on the network share. So it all depends on how you have your backup strategy and your policies inside your organization. Alright, now that we're in Virtual Center, let's go ahead and deploy the data recovery appliance. So what I'm going to do here is I'm going to go to Hosts and Clusters, and from there I'm going to click on File, and we're going to go to Deploy OVF. I have it locally on one of my hard disks here, so what I'm going to do is I'm just going to browse to it, and there it is. Now once you try to install it as part of the deployment process, it's going to prompt you for setups. So what I'm going to do is I'm going to kickstart that wizard and click on Next. I'm going to keep the name as the default. We're going to deploy it in production here, and I'm going to go ahead and put it on storage 2. As far as the network is concerned, I'm going to deploy it on my VLAN 213. Now at this point, it's detecting that VLAN 213, the VLAN that I've chosen, has no DHCP enabled on it. So what I'm going to do is I'm going to accept this default, and then once I have the virtual appliance up and running, I'm going to go in and we're going to assign it a static IP address. So what I'm going to do here is I'm going to click Next. As far as the time zone is concerned, I'm in Central Time Zone, so we're going to go ahead and select Central. And that's it for the wizard. So I'm going to click on Finish here. It's going to go through the deployment of this virtual machine. And you'll notice that's already been added to the inventory, so it's just a matter of time before the wizard completes and it's completely added to the inventory. Now, once it's added to the inventory, the first thing I'm going to do is I'm going to add a second hard disk to this virtual appliance, because that second hard disk I'm going to use for the purposes of this example as my destination disk where we're going to back up everything to. So once this thing is done, we're just going to go into the settings, we're going to add another hard disk, we're going to give it its capacity, and then we're going to use that as the destination. We're going to close. I'm going to right click on it, we're going to go to Edit Settings, we're going to do an Add hard disk, next, next. Let's go ahead and do 100 gig. Next. You guys have seen this 100 times, so we're not going to spend much time on that. So the secondary hard disk has been added, so what I'm going to do now is I'm going to go ahead and power it on. Let's go through the summary tab. I like the summary tab. And yes, we want to power it on the suggested ESX host. That's part of DRS and HA. It's an initial placement. We've covered that in the DRS and HA. I'm going to go ahead and open its console here. Now you'll notice this appliance is based off of CentOS. If you reboot at any point, it'll show you that it's CentOS, another iteration, another version of Linux. Now you'll notice here it's pausing on the Ethernet connectivity. It can't see Ethernet, so this will most likely fail here until we give it a static IP address that allows it to communicate with the rest of the network. There you go, it failed. So now we're going to rectify that once the appliance is up and running. Now this appliance also, once you give it an IP address, you're able to log on and do some configurations as far as this appliance is concerned from a web page. And once we give it an IP address, I'll show you where you can go, and we'll log in, give you show you some of the settings that you can do from the GUI interface as well, from the web GUI interface. Alright, so the appliance is powered on, it's fully operational at this point. You'll notice here that it's not getting an IP address, so this would be the IP address that you would point to in order to get web connectivity to this appliance. So what I'm going to do first is we're going to go to where it says Configure Network. Now it's asking us, do you want to use a DHCP server instead of an IP address? The default's no, but I'm going to go ahead and select no here. I'm going to give it a new IP address. So what I'm going to do here is, let's clean this up. Let's give it an IP address of 10.12.112.201, and we're going to give it a subnet mask. We're also going to give it a gateway. DNS is important. The appliance has to be able to resolve the IP address of the ESX host, otherwise you're going to get errors when you're trying to do a backup or restore using this appliance. So make sure that your appliance is able to ping your ESX host via name. So that's very important to keep in mind. Those are one of the gotchas that I've learned doing vSphere for a while. As far as the host name, I'm just going to do DR. And I'm not going to give any proxy settings as far as internet connectivity. Is all of this correct? We're going to go ahead and say yes, and voila. At this point, this is the IP address that I can use to connect to this web appliance. So let's go ahead and try connecting to this appliance on that IP address. And there it is. So in order to log in, the default user is root, and the password is VMWare, except instead of the A in where, you're going to use the @ sign. And voila, once we've logged in, it's going to display information about the appliance, and we can go to the time zone here if you wanted to change the time zone, for example, save settings, cancel changes, etc., etc. Not a lot to do within from the web GUI, but it gives you the opportunity of changing some of the system settings, and you can go into the networking tab here, and you can also change some of the settings for the network. So it can come in handy if you need to go in through the web. For the purposes of this demo, we're going to go ahead and close out of here. And what we're going to do at this point is we're going to close the console. We're also going to exit out of Virtual Center. And what we're going to do is install the plugin for Virtual Center so that we can manage this appliance from within it. So I have it on my D drive here. And I'm going to go ahead and let's go ahead with the auto run. I'm going to select the first option, which is the Data Recovery Client plugin. That will kickstart a very basic wizard. I'm going to go ahead through the settings here. Next. I have no choice but to accept. Next. Next. Close. We're going to exit out of the wizard, and then we are going to log back into Virtual Center. Alright, once we're in Virtual Center, you're going to notice here down where it says Solutions and Applications section, you'll notice that we now have a new icon for VMware Data Recovery. So if I go ahead and go into the VMware Data Recovery, the first thing we have to now continue the setup and associate Virtual Center with the appliance that we've just added. So in this case, as soon as you click on the VMware Data Recovery, you'll notice that it highlights the appliance that it found within the inventory in bold. So if you had more than one appliance, then it'll highlight more than one and allows you to choose which one you want. You can always set the name or IP address or DNS name of your appliance here and connect to it. I'm just going to go ahead and double click on VMware Data Recovery. You'll notice it'll automatically populate it and automatically try to connect to it. Now it's asking what's my username and password to connect to Virtual Center. It automatically populated the administrator. I'm going to go ahead and give it the password, and voila. Now that it connected, it kickstarts another wizard, asks you a few more questions in order to configure and get the data protection appliance ready for use. So what I'm going to do here is I'm going to confirm my credentials for Virtual Center once again. Now it detected the additional hard disk that we added to this appliance. It's a local hard disk to that appliance. It found it, so what I'm going to select it here. Now what you need to do before you can use this appliance, at this point it's just a disk, it's just storage. You need to format this disk in order for the appliance to see it as local disk to it. So what I'm going to do here, and before we talk about that, you have several options of adding disks to this appliance. You can add a network share if you wanted to, and you can mount. So in my case, what I'm going to do, because I have local disk attached to it, I'm not going to use the network share. I'm just going to go ahead and format. Now obviously it's prompting you here that, hey, we're going to use this as the backup store. Click OK to format and make sure there's nothing that you want on it, because I'm going to destroy everything on this disk. I'm going to click on OK. It's going to take a little bit of time here, a couple of minutes maybe, to format this disk, and when it's done, we're going to be able to use it. And voila. It now shows the disk as usable. It's giving me the capacity, it's a local volume, etc. So what I'm going to do here is I'm going to click on Next to continue. And then I'm going to keep this checkbox selected so that we can create a backup job as soon as... Actually, let's uncheck it, go through some of the settings, and then we'll create a backup job manually. So what I'm going to do here, now that everything is configured, everything is done, we're going to close to exit. Now, once you're in the VMware Data Recovery screen within Virtual Center, you'll notice that obviously you have the Getting Started tab here. You have the Backup tab, and we're going to talk about how you create backup jobs. The Restore tab allows you to use jobs to restore. Then you have the Reports, which is going to list everything that happens, all the tasks, successful, unsuccessful, incomplete, etc. And the Configuration tab here, you have the option of using the Getting Started wizard again. So that wizard that we just completed, if for whatever reason you want to go through that wizard again, maybe add another local disk or some type of disk, you can always go through the Getting Started wizard. You can always change the time. You have access to the log. And of course you have access to the destinations here. Again, if you want to add another destination manually rather than go through the wizard, that's where you would do it. You have access to the backup appliance, and all the information for that backup appliance is located here. You can also click on Set Virtual Center Server or ESX Host Credentials. So you can, if you've changed the credentials, you can come back in here and make sure you set them accordingly for the data recovery appliance. Otherwise you might get some errors when you're trying to do a backup job. Now, there's not really much to do in VMware Data Recovery. The appliance is very straightforward. It's a very simple interface. So what we're going to do now is we're going to go ahead and create a backup job. So I'm going to go to Backup, and you can always come up here and click on New. What I'm going to do is I'm just going to right-click, click on New here, and I'm going to browse through my Virtual Center hierarchy, my virtual center inventory here, and select the virtual machine that I want to back up. So we're going to go into production. Now I'm going to pick on VMFS01. Now you can select the checkbox for VMFS01, and that's just going to take the entire virtual machine, all of its components, all of its files, all of its VMDKs, or you can expand it, and if you had, for example, more than one virtual disk and you didn't want to back up both of them, so let me show you an example with MPCTX Icon 03 here. You'll notice that I have two virtual disks, so I can select one or the other. For the purposes of just keeping it simple in this example, we're going to stick with VMFS01 and one of its VMDK files. We're going to click on Next. We're going to use this destination target for the local disk. Now here's where you have the option of specifying when you want to do the backup, what times you want to avoid. Now you'll notice that in dark blue here, run backup job. So it's allowed to run the backup job wherever these boxes of blue you see, and then where with the gray area here basically tells the backup job do not run during this time interval. And if you'll notice, by default it's set from 7 to 5, which means during business hour from Monday through Friday, during business hours, I do not want you to run any kind of backup jobs that might interfere with performance and productivity. Just do it after hours where nobody's using the system and you have full access to all the bandwidth and you don't interrupt anyone. So this is just best practice. Feel free to tweak this to your liking. I'm going to click on Next. And here's where you set how often you want to back up. You have a lot of settings here. You have some default settings that you get by default. So if you click on Few, you'll notice down here that the policy preserves at least 7 most recent backups, as well as, and you'll notice here, 4 weeks worth, 3 months, 0 quarters, and 0 years. Those are the most recent backups from each of the last 4 weeks, 3 months, etc., etc. Now you can be a little more aggressive. You click on More. You'll notice that the frequency is the same here, 7 most recent backups, but you'll notice now it's added 4 quarters and it's added also 1 year. If you go to Many, then it jumps to 15 and these values changes, and then obviously you can always click on Custom and put in the values that you want. So I'm going to keep it at Few here. We're going to click on Next, and this is basically a description, a summary of what this backup job is going to do. If you're comfortable with it and you want to proceed, we're going to click on Finish, and voila, you'll notice down here that it's giving you a status of what it is that this backup job is doing. So in this case, it's creating a virtual machine snapshot, it's scanning VMFS01, etc., etc. I'm going to let this run here. This is really cool, and as you guys can see, this is really easy. So each appliance can have a maximum of 100 backup jobs, so make sure you scale that up or down accordingly based on your organization and the size. And if you want to rely completely on data recovery, on the data recovery appliance to do your backups and restores in the virtual environment, you have to understand that there's a maximum of 100 jobs that you can run. And each backup job can have a maximum of 1 destination. So you can't have more than 1 destination per backup job. You're going to notice down here that the backup job is now completed. The status is waiting. Let's go double check the reports to see if the job was successful. You'll notice here that the backup job that we ran was successful. You can always dig down to take a look at some of the more details. Now if we go into the Restore tab, you're going to notice that it displays the hierarchy of the inventory, and the virtual machine that we currently have backed up is VMFS01. I can again drill into this virtual machine and select the components that I want to restore by checking the box. Or if I wanted to do the whole virtual machine, then just check the box next to that virtual machine. Now as far as running the restore job, that's real easy. Focus your attention up here to where it says Restore. We're going to click on Restore, and we're going to go through a wizard again. We're going to click on Next, and then we're going to click on Restore. And voila, you're going to notice here that you're going to see a status bar that allows you to track and monitor the progress of the restore job. Restoring virtual machine, I'm at 6%, now 8%. We're going to go all the way to 10% or 100%, and that would be the end of the restore job. And you'll notice that the job here has been successfully completed. The virtual machine has been successfully restored. Now you'll notice that it went very quickly. Because we're backing up the disk and we're restoring from disk, it's very easy and very quick. Depending on the size of the virtual machine that you're trying to back up, the restore process will go very, very quickly. So in a nutshell, this is how you do backups and restores using the VMware Data Recovery appliance. Now for those of you that are in larger enterprises that have backup systems, you're going to want to integrate your virtual infrastructure backup and restore strategy with whatever it is that you're using as far as an enterprise backup and restore system. But for smaller environments that don't want to have an investment into some of these backup tools, and for simplicity's sake, you guys saw how easy it was to back up a virtual machine and then to restore it again if need be. And that's a wrap for this module, folks. We hope it's been informative for you, and we'd like to thank you for viewing.